So let's start this graded homework set 3. And the idea here is that we are given a equilibrium reaction, and then what will be the value of KCB when it is written as this one. So this is just where you remember what to do. So this, for example, the HD has to end up on this side. So we're going to have to reverse this around, and that means Kc, when we reverse a reaction, we invert the K. So that has to be done to make it reverse direction. And then in fact, for example, we have to end up with 6 HDs. That means we have to multiply by a factor of 3. And that means the whole thing has to be raised. So we're multiplying by a factor of 3. The whole thing has to be raised to the 3rd power. So if that's done, the answer turns out to be one of the choices given, and that's problem 1. So here is problem 2. Which of the following statements is false? And so the way we do this problem is just to consider each statement and determine whether it is true or false. And we start with number 1. K is much greater than 1 implies that the reaction is very fast at producing products. Now, the K has nothing to do with the rate constant. The K is about equilibrium, how much product. So that's not true. But let's go on and consider the others just to make sure that that's the one that is actually false. So second choice, when K is less than 1, the reverse reaction is favored. Remember what we have here is that these end up being the product's concentration over the reactants. So when K is much less than 1, that's saying the denominator is much larger, and that means it's reactants that are much greater. So that is in fact true, right? As reactants are favored, K is much, much less than 1. The next choice, when K is much greater than 1, the forward reaction is favored and essentially goes to completion. That's true. It makes mostly products over reactants, and that's a true answer as well. And then when K equals 1 or approximately 1, either the forward reaction or the reverse reaction is strongly favored, and about the same amount of reactants and products exist at equilibrium. That's right. We have whatever concentration of the products is divided by the same concentration of reactants. That's going to give an equilibrium constant of 1. So those are true, and in fact that first one is the wrong answer. So here's question 3, and I've already drawn it in here. It gives us this reaction, PCl3 plus Cl2 gives PCl5, and then it gives us what those equilibrium partial pressures are. So we put that into the relationship that describes what K is, products over the reactants, and then I put in these values, and you solve that. You just do the multiplication and division. And so in this case, if I do that, the answer I get here is 66.7, and that's the equilibrium constant at pressure for this expression. And then here's question 4. So for which answer will Kp equals Kc? And then I've written out the relationship between Kp and Kc. And the difference between the two accounts for the change in the number of moles of the gas. So in this case, for Kp to equal Kc, RT has to be equal to 1, and that happens if delta N is equal to 0. So if this is raised to the 0 power, this term RT becomes 1. And delta N, which of these, is there no change in the number of moles of gas? We have gas on the right in all these. Down here in the fourth choice, 1 mole of O2 gas, 1 mole of CO2 gas, so delta N is 1 minus 1, and that's the answer that gives us a delta N is equal to 0. So the RT term becomes 1, and that's question 4.